So that's it for housekeeping. Let's go ahead and start on today's webinar, how observability relates to DevOps, SRE, and cloud native. So my name is Fong-Jones, and I'm a principal developer advocate at Honeycomb. And I'm joined today by George and by Fred. George and Fred, welcome to the show.
Hey, good to be here.
Thanks. Glad to be here as well.
Maybe you can share a little bit about kind of who you are, what you do, how you kind of relate to this content that we have.
Sure. So hi, everyone. I'm George, co-author of the book along with Liz. And I currently run ecosystem and partnerships at Honeycomb. You can find me on Twitter at gmiranda23.
I'm Fred Hebert. I'm here as the representative of the SRE role within Honeycomb because it pertains to a chapter. I did not participate in writing the book, but I'm glad to be here to talk about its contents anyway.
And Fred and I definitely worked on a lot of the things that wound up making their way into the book. So yeah. And I guess to kind of close out why I wound up being the person who wrote this particular chapter that we're going to be talking about today, which is chapter 4 of the Observability Engineering book. I originally wrote that because I've been involved with the Cloud Native Computing Foundation as a OpenTelemetry governance committee member, and I also previously was an SRE at Google for over 10 years. So that kind of is why I kind of wanted to relate these two concepts together of like, how do these words that people are talking about in the ecosystem relate to this observability thing? But before we get into the kind of newer subjects of SRE and Cloud Native for this webinar series, let's talk first about what we covered in the first couple of webinars, because we have a couple of people who are attending a webinar with us for the first time, which is great. So let's just make sure that we do a quick level set. So George, kind of when we were talking through episodes 1 and 2, I remember we had this kind of discussion about starting with structured events. Kind of what is a structured event really quickly, George?
Yeah, so the idea with structured events is trying to find like the smallest relevant atomic unit for understanding your system, right? And so as opposed to monitoring practices that generally rely on metrics, which are an aggregated view of what was happening, in a particular aspect of our system, the idea is to get to an atomic unit that makes it so that when you are investigating problems, you don't run into dead ends, right? So if you are trying to figure out what is happening with, a slow aspect of performance, and you're trying to look into bits of your system, and you see, a metric that tells you that, there were this many threads opening or this much CPU being used, can you actually tell what's happening behind that, right? Can you dig in a little bit further to understand what's happening? And so a structured event is basically, one, it's a record of what happened for a unit of work in your system, typically at the per request, per user level, right? More or less a log or a distributed trace of everything that happened in order to complete one action. And the idea why that is the relevant atomic unit is for any performance issue that you want to investigate or any system issue that you want to investigate, how can we dig down to understand what was the context of this execution of code, what was happening at the time, right? Can we get down to the point where we can understand anything from an aggregate system overall view of what's happening down to, the individual requests that, comprise that overall system performance. Right. So
yeah, it's definitely really exciting to see how events bridge the gap between kind of the traditional signal types that people talk about in terms of traces or logging or metrics, because you can compose any of these data types out of a structured event. So that's what we talked about in the first session. And in the second session, we talked a little bit about kind of the differences and similarities between observability and monitoring, and about how they're complementary in some ways, how you can use system metrics side by side with application events in order to get a better view of your system, rather than trying to use system level metrics to measure your applications, which fails at larger scales and with more tenancy and users. So that's what we covered before. But today, what we'd like to do is we'd like to get into the implications that these things have for practitioners of site reliability engineering, and also for people who are working in the cloud native space. So, like a lot of people, I had a lot of skepticism about this kind of cloud native thing, because it turns out that getting a definition of cloud native is really, really hard. You look at this sea of logos and you think, oh my God, how am I supposed to get a handle on this? I don't know, Fred, what was your reaction to seeing the cloud native computing foundation landscape for the first time?
We went wrong somewhere as an industry to end up with this sort of landscape. That's my gut reaction to it. And if I were to be a customer of at least one of them in each category, just how expensive would it be? It just is intimidating as an image.
I think part of this relates to kind of the focus on products in the Cloud Native Computing Foundation landscape, which is great for George in his partnership role, but kind of less great for us as practitioners to wrap our heads around kind of what's going on here. So let's actually simplify and break this down, right? There are all these things, saying, is it databases? Is it runtimes? Is it X or Y or Z? But the answer in my book is cloud native is about enabling us to deliver faster. We can think about kind of the previous shift onto cloud technologies. We were doing lift and shifts, right? When I was at Google Cloud, we were helping customers migrate on-premises workloads onto the cloud. And there was literally, replacing physical machine for virtual machine, or replacing virtual machine for a virtual machine, right? It was kind of this kind of inflexible model of we're used to the world of machines, we're going to keep on working in machines. And what cloud native fundamentally is about, instead of this gobbledygook landscape to me, is about this kind of capability to ship faster. That if we use technology, certainly Kubernetes is kind of the first of these large scale projects. If we can start doing container orchestration and scheduling, that means that we can only scale small atomic units of compute, and to deploy microservices and kind of deploy binaries just to kind of one slice of the infrastructure very quickly without needing to churn virtual machines.
I think that's true, Liz, but there's a little bit of a shift that happens here too, right? Like with cloud native, it's really easy to start on day 0, but like your day 2 problems end up being significantly more complex, right? And so in some ways, what we end up doing is shifting complexity. And so there's a quote, it's not in chapter 4, I think it might be in one of the earlier chapters, but Larry Tesler, right, the guy who invented copy and paste, it's probably my favorite quote in all of computer science, which is every application has an inherent amount of irreducible complexity, right? The only question is, who has to deal with it? Is it the end user? Is it the application developer? Or is it the platform developer, right? And like somebody's going to end up with that complexity. And it seems like what we've done in cloud native, right, is we've made it way, way easier for application developers to get rid of that complexity, right? Because if everything's containerized and you're coding it the same way, right, it should be easy to just take that code and ship it, right? And for the end user, they just experience our services, right? And if we're doing it right, they're snappy and responsive and they're always available, right? So they don't see any of it, which means who got all the complexity, right? It has gone to the platform developer. And I think it's clear when we look at that ecosystem landscape, just what kind of complexity we're talking about.
Yeah, I think the interesting thing there definitely relates to, how do we enable developers to ship faster? And even if it shifts the workload around to the platform owner, I think that platform owners are better situated to kind of think about concentrating this expertise and developing the right patterns rather than have everyone invent them from scratch. Now, Fred, I know you worked at Heroku before Honeycomb previously, so kind of maybe you can share a little bit of your experience kind of operating one of these first kind of serverless or cloud native platforms as a service.
Yeah, specifically I was on the routing team and I handled also the logging applications 6 years ago, well, 10 to 6 years ago or something. So it's not super current, it's not all the information about it. But a lot of that complexity is handled, each of these boxes represents a business because there's enough complexity to be able to sell it to someone. So you look at this as like, oh my God, this is complex. There's a lot of stuff, but there's a reason people are able to do that, right? Someone invented copy paste. There's not a copy paste startup in that chart because it's sort of solved. And the sort of thing that happens is that when you get into a bigger team with a platform complexity and everything like that, is that some of that needs to be tackled by someone. If the abstraction is clear and well delimited, then it won't be leaky and you won't have the emergence of having to make everything fit together. But it requires a lot of very, very careful designing to make sure that the surface area looks smooth and polished to people from afar who are using it. And internally, it does require a lot of observability, the telemetry that you want to have in it, and the expertise of the people running the systems is sort of an essential thing to keep it going all the time. Yeah, and if you don't have that, you might have the product, you might have the components, you might have the containers, but nobody really knows how to wrangle them, where the inflection points are, and that becomes like an integral part of everything. Is, of course, you have to have the careful design and everything, but you have to treat it like a living beast or like a garden that you keep going and people are the caretakers for. Without that, it doesn't work.
I think in
brings us
chapter
to this.
4
Go ahead.
is probably the first time, at least in the book, that we sort of address observability as a property of your system, right? Similar to testability. So observability, just like testability, is a measure of how well you understand everything that's happening, or just like how many permutations of things can you understand. And observability, just like testability, is a continuous investment, right? And it can and continuous improvement, right? It's not a one-time addition, right? Or a handy like one-size-fits-all solution. It's a thing that you're going to have to care and feed for and evolve over time.
A lot of teams and products have concerns about user experience, but there's also the flip side of that, which is the operator experience. They are users and people who interact with the software all the time. And generally, there's not a lot of care in there because they're developers, engineers, they have access to internal toolings and all sorts of stuff. But that's the thing, right? They're like power users who are really, really used to having terrible tooling. And having that better observability, well-defined control mechanisms and whatnot helps make the operator experience much better. And like a user gets more productive when they have a good user experience, the operators get more productive when they also have a good operator experience.
So I think this brings us to this next subject of kind of site reliability engineering as kind of the keepers of the platform. Right, that we are the people who think about how to run these systems, and therefore we demand observability for us as the people who run the platform, as well as for our application developers. But let's back up a step and make sure we talk about some of this history of SRE and DevOps. Right, that the Google SRE book came out in the mid-2010s and was influential for a lot of people because it was this kind of encapsulation of Google's opinionated way of doing things. And it's evolved since then, right? Like, not every SRE, and indeed a majority of SREs no longer, have worked at Google in the past. And I think it's important to think about how we use these principles to better operate platforms. I think that kind of this platform engineering direction has definitely come to the forefront.
Yeah, I think to your point, Liz, right? Like we blew up the monolith, right? And now SREs or platform teams, right, have sort of these big complexity problems to deal with. And I think what I want to frame is that I think this chapter that we're talking about is kind of a little bit of an unsung hero in the book. So meaning there is an SRE book that covers a lot of SRE practices, and observability is a practice in that toolkit. And so like we could have spent more time there, but it sort of ended up a little bit on the editing room floor, right? Which is exactly what
there are three and a half books about SRE, right? Like there's the SRE book, the Site Reliability Workbook, Seeking SRE, and then the SLO book, right? So those are kind of the 3.5 books that kind of cover all of SRE practice. But I think kind of most relevantly here, we should think about how SRE has focused, a lot on the how do you, lower your toil, how do you keep your systems operable for the long term. And in parallel, right, like I think the other thing that I wanted to mention earlier is that, the SRE book, was published in the mid 2010s, I think like 2016 or 2016, 2017. But it didn't come fully, sprung from the head like Athena, right? Like it was something that was also steeped in the DevOps movement, that DevOps focused a lot on shifting things left, on enabling software developers to own their code in production and to think about those delivery cycles. So kind of these two things have come together, initially in parallel, and now they've converged into one single movement. Oh, Fred, yeah, you're pointing out I missed a book, the Jamie Wu 99 Things That SRE Should Know.
Yeah, to your point, Liz, I think when it comes to debugging, right, going back to the quote about irreducible complexity, right, we sort of have to understand what's happening on all sides of that, right? Like with the user, right, how do we measure real user experience and understand how users are experiencing our applications, right? So that's kind of observability for front-end applications, right? And measuring, UX issues or things that we can do with SLOs, right? To your point. On the application side, right? Instrumenting our applications, looking at observability-driven development, right? Which is something that we'll talk about in future episodes. And then really understanding, what's happening on the platform level, right? So really understanding, your front-end applications, back-end applications, infrastructure, right? And how do you find problems in any of those? So I think that's what we're gonna, hopefully unpack a little bit in our session today.
So I think that, next we should maybe think a little bit about what does observability look like when it's kind of integrated into a shift left workflow, right? Like, so at Honeycomb, we definitely have, it was interesting for me seeing how much we focus on observability as part of how we deliver on observability for you all out there, right? Like, I think it's notable that when you submit a pull request at Honeycomb, part of the pull request template and part of what your code reviewer is looking for is, did you make sure that you maintained that observability standard, right? Like to think about observability not as, it's one and done, but instead kind of how do we cultivate and maintain observability? So one of these pull request template fields is like, how do you expect to observe the results of this change in production? And Fred and I actually had a exercise in this morning. Fred and I were pushing one change, and we were like, okay, wait a second, like how are we going to observe this? And Fred went and looked at the observability data, and it told him.
Yeah, we were rebalancing something, and as we're rebalancing it, we saw another metric jump up at roughly the same time. That was not yet alerting, but was a sign of problems to come if nothing would be addressed. And Liz and I had a bit of backstory on this, but by accidentally looking at this other correlated metric, we knew that something else was not shifted or modified a few weeks ago with another change that it was now interacting. We had about 15 minutes to do it. Knew the solution could do everything, but maybe half an hour before this presentation, we avoided an incident by just having data around and looking into how we're going to confirm that the first change is correct and rapidly catching the second issue that was bubbling up unannounced.
So you always can expect unforeseen things to happen, right? I think that's what it boils down to, is that if you are not kind of elbows deep in your data, kind of both the surface level kind of monitoring data about what's purely externally visible, but also the kind of ability to dig into that internal state. If you don't have both of those capabilities, then you're not going to be able to get into what's going on inside of the system. So kind of that observability plan is really, really key to making sure that engineers don't lose grasp on what's happening in production.
I think I want to frame a little bit about the conversation or what we're going to get into, right? And so when it comes to the observability book, right, I will say as we were writing it, it was all about trying to be as objective as possible. And in doing so, there's a little bit of context that's lost. So I see in the chat, David Raystrick made a comment about platform engineers and how back in the day, like those were really just called sysadmins. And back then, I actually worked with David at Electronic Arts, and I know that any of the shops that I went to after that, and for probably anybody on this call that is in a platform or SRE or DevOps team, it feels like practices change from team to team to team, and they do, but there are some things that are, like hopefully concrete along the way. So I unpack that all to say, one of the reasons that in this webinar, we want to look at how practices are shaped at Honeycomb is we want to make things a little more tangible, right? The book is all about observability as a practice and sort of the data that you need and how you need to analyze it and what the patterns are. But what is that? How does that look in terms of day-to-day operations, right? So let's break it down a little bit, right? And just talk about how observability changes practices at Honeycomb.
Yeah, so I think Fred has put together some interesting material for us about the feedback loop between, not the thing that happened this morning, but kind of a little bit more in depth of a look into something that happened a week or two ago.
Yeah. So I mean, this is a general thing, right? There's multiple aspects in how we use it, and this is two components. On the left, we have the sort of automation of it. And you can see that there's triggers. There's one of the things that we have about the automated deploys. One of the things that's super subtle about the triggers is you can see that there's in brackets eng for engineers and Kafka under replicated partitions, and that's because internally within the company, there's a big usage of our triggers and our observability data that is used by customer success, support, people in business operations and everything to know what is going on. And we're no longer the only users of alerting. And whenever we hand off the pager, we have to filter through the triggers to see if any one of them is in there. But if we have hundreds of them and only 50, 60 are for engineers or something like that, we have to be able to quickly filter through them. So we have to evolve these little things that let us know about, this Kafka under replicated partitions, false alarm and everything. The Circle CI one about the deployments is the one I sort of wanted to focus on here, because there's the surface triggers area, but we also have an API, and this is the code on the right. It's ugly bash code because don't care. It's running in CI and everything, but we have three environments. Production goes into dog food, that goes into kibble, and they're all monitoring each other's. They're private copies of Honeycomb, and they're monitored the big production Honeycomb for everyone. And we essentially use the SLO and SLI feature to create instant requests to our internal APIs using the API feature that exists. And what we do, and this is the box at the bottom, is we look at the SLI from the previous deploy and the current deploy that's simmering in pre-production environments. And so long as we have a degradation in more than 2% of what we have, we stall the deployment. It no longer goes out automatically. It used to always go through, and we have to click on the little view job button to analyze, see the graph and everything, and decide if we still promote it or we hold it back. And that's the basic thing, is automation like that. We're careful about it. Most toolings give you the automation easily, but to me, it's not the most important part. But before we switch to the next one, is there anything else you wanted to point out?
Oh, I wanted to say, like, hold on a second. We haven't talked about SLOs and SLIs yet, and we will have a webinar on that. But we should probably really quickly define kind of, we're SREs. Fred, you and I are SREs. We know what SLOs are, but maybe we should talk briefly about kind of how SLOs have impacted how Honeycomb thinks about things.
Right. So the big thing about the SLO, the service level objective, is the way we also build the SLI, the service level indicator. And rather than being based on an aggregate value of 99 percentile of request response and everything, the SLI that we have, the indicator, is a derived column that lets us know, like, was this event successful, a failure, or does not apply? And we do that on a per event basis. So every single request, we know if we consider it successful or a failure. The SLO takes all of these, puts them together, and tries to meet a given objective. We want to have 99.99% of them succeeding or not. What we do with the build API here is we actually disregard the SLO. We don't care about the objective. We use the SLI column, And without the objective, we just look at whether it was better than the previous one we had. We don't necessarily care about meeting the objective in the pre-production environment. We just want to make sure that it's not degrading whatever was there. We're not on call for the pre-production
in a
environment at the
nutshell,
same
essentially,
level.
what you're saying, Fred, is that the SLO is how we measure success. And in our build automation, we've wired Honeycomb to check whether we are degrading more than we should be or more than the previous build.
Yeah, if it's stable, if it's good, if it's better, right? The objective is not necessarily there for the pre-prod, but we want to know if we're maintaining a baseline of success that's similar to what we had before.
And one of the things that I want to point out, in case it wasn't clear, right? In most of what we talked about, we weren't really actually talking about like the practice of observability necessarily, right? But things that you are doing with your observability data, right? Like informing progressive release patterns, right? And whether or not, you know, this deployment degraded performance, and if so, go ahead and stop it, right? Which isn't necessarily—
Go ahead and stop it, and then use the observability data to dig in, right? It's the same data, right? You don't have conflicting data because this is all the same data source that is fully granularly debuggable.
Right. It's the old idea that you never buy a hammer because you love hammers. You buy a hammer because you have something you want to nail somewhere. And so the observability data is not the thing I'm passionate about, or I care really much about having the numbers, but what can I do with this data is a lot more interesting. And this here for this image is the stuff that follows with the incidents. We're now using Jelly to do incident analysis. We have a well-known prefix for the URLs for all the queries. And so we, for example, have preset things where for the duration of an incident, all the queries that were used are part of that. And we had a near miss or small incident a couple of weeks ago where it was a repeat or had similar elements to one that happened last year. And we're able to go look into the old queries, find the things, and reuse the queries easily in current times to see if the patterns were similar or not. But we also use them in incident reviews. The image to the right is the big Kafka outage review we published a bit more than a year ago. And this is the sort of communication that we do internally. We take this image, that's the overview of this 18, 20 hours incident, and it gets annotated to show the big motions and the things that were happening. So they're useful to debug the system, but they're also useful to take a step back, have a higher level of thinking about it, see the patterns, the motions, and then tell the story about that to people who joined even after that happened, because this is how sometimes we fix systems. And this is useful support about that.
Right. It's when we talk about observability, we're not just talking about the technical data, right? We're talking about the ability for us as humans to both understand what happened in the system and also communicate about it to other humans, right? That a system that is only observable by one person on your team is not actually observable to the entire team. Right, so we have to make sure that everyone on the team, right, even if they weren't even working at Honeycomb back in December of 2021, can still understand, you know, what happened during this outage, how can we diagnose if a similar thing happens again, and how do we recover, and how do we debug, right? Like these are all things that we have to be able to learn from, rather than being doomed to repeat the past over and over and over again.
Right, and to add more weight to that, none of these charts are useful in isolation. They're all useful in context where you can see the chat discussion that was around them, what people were looking at. The thing that was significant is not necessarily obvious in the chart, but it usually comes with, hey, I was expecting this and I'm seeing this right now. What could be behind that? Or, oh, I'm seeing this on this chart. This explains the effect we were going on, spotting the correlations or whatever. It's all very, very contextual. So the data is a pivot point that's sort of interesting, but that's the image on the left there where we have that sort of discussion. No, that was a good switch, right? This is when we're in Slack. You know, queries are still failing. Something is still off. What happens if we just ask for more things, browser things, and then we're looking at internal data? Like, does the internal data we see explain the thing that happens in the browser? the name is censored, but this is my face. And then the other engineer is like, no, look, we're not having the 201s and everything. And everything that's happening, this is a distributed company, but we're looking at the data and we're able to tweak each other's query and refine them in each time to see like, oh, you're looking at it that way. Have you tried this angle? If you add this thing, you get something different. And that becomes a social debugging effort. This is something that's very, very different from what I've seen in different companies, where you have what is essentially the council of the dashboards, the people who are the query crafters, who understand the metrics, what they mean, and they're there to be the oracle that interprets everything for everyone. And the thing that we see with the query building and the data that's understood and everybody understands and sees the importance of it, is this social debugging thing where we send data, we refine the queries, we have the history, we take the best one, it goes into the report and everything. It becomes an entirely social and collaborative act to debug a system rather than deferring to whoever made the dashboard and remembered what happened and why it was important back then. That's a very, very different dynamic from just having the data. The other image that we had on the right in the previous slide was the template that Liz talked about the incident observability plan, not the incident, but the pull request. So every pull request has a thing. What are you going to look at to prove that your change was going all right or not going properly and everything like that? So that's a pull request that was open last week. That specifically when if we're looking at this, this is going to be a problem. Otherwise, this is what we expect to see when this change takes place. And that was about a feature flag.
Well, I want to point out there, right, that like similar to testability, right, that's essentially what we're talking about, right? That is, what is the ongoing verification when this thing is running in production that tells you that this thing is operating as you expect, right? Yep. So as new features are deployed, right, what is that live test in production that's going to tell you that, you know, this thing is...
It's almost like an improvement over testability, right? In that testability of your code will tell you whether it's going to work in pre-prod. Mm-hmm. But observability helps you know whether your code is working for real users in production. Yeah. So I think you need both, but...
Yeah, I mean, if I compare it with being in a hospital or something, how you test medicine or something like that is very different. But if you're having a high temperature and you're trying to lower it, there's a very clear, we expect the temperature to go lower once you've received that treatment. And if the temperature is not going lower, then either something is wrong with the treatment or the condition is very, very different. And these metrics are that compressed idea about, given all the context, this is what we expect to see. This is the scientific method of given the change, I'm hoping to see this happen, and then we can confirm or contradict the hypothesis that was made. It sort of tells you like you're expecting to see this change.
Speaking of the scientific method, let's talk about this chaos engineering experiment that's being shown right now.
Yeah, so this was from last Wednesday. There's this system that we have to evaluate everybody's SLOs, where we know there exists a top limit. We didn't necessarily know where it was in capacity, and we wanted to try capacity planning, but the pre-prod environments don't look at all like the things in production. And so this is a part of the board that we had where we ran the experiment. And you can see in the bottom left, what we have here is essentially a feature flag where we were able to tweak the deletion rate of the thing we wanted to test and raise it. The top chart to the left with the big red box, those are CloudWatch metrics from the RDS instances that we have in production. And we're able to match the increase of CPU and the disk queue and all of that with the settings that we had. Top right, this is the deletion rate as seen by the program. And you can see the internal failures happening. If you look at the sort of black line that's in all four charts, at that point, we put the deletion rates to 1,500,000 deletions per batch. But the count of deletion in the top right entirely goes down. So the deletes started failing. But we also had the graph to the bottom right, which shows the external, what customers see about whether they see the failures or not. So we're able to say like, okay, we're having failures right now. Nobody's seeing them, but we know that we found our limits. And then the other dips that you see at the top right are us trying to find the in-between point and investigate the error and recausing it until we find, okay, this is this database call, and we're getting out of too long waiting in a queue, and then we're aborting. So this is the hard limit that we have. And the experiment took 30 minutes, 45 minutes. Nobody saw anything, but we were able to guide the entire thing and the entire experiment by looking into all that sort of observability data that we have strewn around the systems that we have, right? The database, the feature flags, the individual components, the SLOs and SLIs, and the things that people see, and all the services. We're able to get that sort of overall view of things we expect, things we see, and drive the experiment with that.
To be a little bit of a contrarian here, I would argue that a lot of what we used during this chaos engineering experiment was monitoring, right? Like it was time series metrics. It was not necessarily, right? Like we happened to be generating it under the hood with these wide events. But unless something had gone catastrophically wrong, we actually didn't wind up using that much of the kind of raw observability data.
No, we used it. We used it once we found where the gaps were, because we saw that hole, and then we knew it was a database experiment. So we went into a different set of traces that we have that are all about database that I didn't show them because a bit more internal data. But we're able to see, like by the caller, what were the errors, what was the specific error that we were seeing, the number of connections that were active at the time, were all right in there. So for these, we were able to dive a bit deeper internally to get through specific traces. Yeah, that would be, that was last week on Wednesday at 3 p.m. Eastern time, noon Pacific. If you want to
Wednesday,
dive
3 p.m. Eastern, noon Pacific. So probably somewhere in here. Let's try that time bound there.
Oh, the deletions are not taking place in that application. They're taking place in Basset specifically, because that's the one where we have the distributed monolith where they share a database between them, which is not clean, but this is what we do. And
what's the span name?
You're probably going to get it if dbcaller exists. Right, and so that's the sort of query crafting that we were doing back then as well.
Oh, I see it right there.
Yeah,
right there.
Yeah, and the markers, I added markers for the entire chaos experiment to be able to see what was going on. So, I mean, you could use bubble up on that one, but yeah.
Yep. Okay, so let's do that. So let's highlight this.
So those were our test failures during the experiment, and that's especially how we sort of found about them. Like, find me the spans that have an error. Look for the value and everything, and there you go. There's a specific.
Delete old SLO counts is busted there.
Right, and if you look into the specific error reason that's given somewhere, we're gonna get it as where DB error context deadline. And so we were able to look then after that on the duration of the timer. If you click on a specific one and see like, oh, the timer was about 60 seconds or something, and we put 2 and 2 together with seeing the queue depth.
Yep. Okay. Yep. 12 context deadline exceeded. Okay. Let's have a look at one of those just to contextualize it for people so they can actually see how this fits into the entire observability picture, right? Like, again, if we had known to create a metric for it, we could have. But I think the point here is that this was already instrumented. It was woven into, entire traces. We were able to find this starting from the failure, rather than presupposing the failure type in advance.
Yeah, that's the part where you tie in the, as you said, there's a time series data, but there's also the preparation for surprise, where the time series is the high level vital we're looking at, the body temperature if someone's having an infection or something. But when you want to dig, you do have something underneath to be able to look into it. Is our pre-prod environment slow?
There we go.
Yeah, there's a lot of.
So there's the timeout, and that's a lot of trace spans. Okay, so let's.
Yeah, that's a very, very large one. I think I found that one with the raw query data for those having the where DB error exists with that one. Yeah.
Let's see if I can find one that takes slightly less time to load. I think actually most of that loading time was on my end trying to render 60,000 plus trace spans. So this is the kind of thing that we mean when we talk about how observability enriches our life as SREs, right? Like, yes, having the right metric in hand is great, but like if you don't magically start off having the right metric in hand, how do you wind up doing it? And I think that that's kind of the exciting piece. Okay, let's go back to our slides.
Yeah, Liz, I think a
So-
great way of encapsulating that was a comment that was generated, I think, last session, right? That monitoring is great when you sort of already know like what failures to expect or like what might be going on. And observability is great when you don't even know which questions to start asking, right? And you really need to find like where something might be occurring is exactly what you're talking about.
Yeah, and that works in all layers of our infrastructure. Going back to the kind of cloud native subject for a moment, right? Like, we run Kubernetes everywhere now at this point, and having that visibility into broken down per host type, for our containers, or having the ability to see where problems are caused by failure to schedule workers, right? Like those are all things that we can debug, in addition to being able to debug the telemetry emitted by our application itself.
Yeah, the sort of reflex is something you can see when, in traditional systems where we're having an issues, my reflex would be I'm going to SSH in, or I'm going to use this tracing capability that exists in the programming language because I was an Erlang guy. There's a lot of that. But for a lot of it, it's just like there's a secret level of layer of tools that we have access to where we go, oh, there's something weird. I'm going to dig in at that level where you're hoping to find data because it has more granular but less accessible stuff. Honeycomb sort of plays that role internally because the data is already there for the most part. And there was an extreme frustration on my part a few weeks ago when, I said we have 3 environments piping into each other. The last smallest environment piped into nothing, and when that one is breaking, it takes like 3 or 4 times the time and effort to debug anything because there's no data about it. It's a good emergency practice thingy, but since then I got frustrated enough that it's now wired back into production, and we have that full circle of all the environments looking at each other because it's just that much easier to debug something.
It turns out it sucks way too much to have to debug only with metrics. It just
right. The thing that I'm sort of worried is that it's still a social process, and so if there is a very big outage where all 3 environments go, then we're not going to have a good muscle for this. I'm hoping it just doesn't happen that much in comparison. It's just not fun to do it for a pre-prod thingy anyway.
Yeah. All right. So we covered a lot of really great and fun content today, I have to say. We talked about chaos engineering, cloud native technologies, SRE, SLOs, DevOps. So if you have any questions about all of that, please drop them in chat or raise your hand. If you do unmute, you will be seen on the recording, just so you know, though. And while questions are coming in, I wanted to let you know that Honeycomb values your feedback. So if you complete a survey about this webinar before tomorrow at 12 p.m. Pacific, noon, we'll send you a t-shirt to say thanks if you're located in a country where we're able to ship. Bethany has dropped the link into chat, or you can scan the QR code on your screen. And with that, let's go ahead and get to some questions. The first question that someone asks is, does Honeycomb support auto instrumentation for Kubernetes out of the box?
I'd say no, it's not like we have an agent that ships with Honeycomb for that, but we do have Kubernetes Metrics, something called KSpan. And
Oh yeah, sure. Let's show them KSpan first. So this is how we keep track of, for instance, which pods are failing. So you can see here that, yeah, we've had a couple of pod backoff failures. Let's go back 14 days so we can see Pyroscope failing there. Yeah. So I had a job that ran out of disk and crashed repeatedly because it has a persistent disk. That one was a fun one to debug.
Yeah. And so for a lot of these, it's not necessarily that, Honeycomb has the tools for that, but you can install anything that generates open telemetry data for Kubernetes, and then it works. So it's not necessarily auto instrumentation out of the box. It's just anything that is instrumentation for Kubernetes we can use. So there's something called the Kubernetes agent. Yeah.
There it is. So it's, Weaveworks experiments KSpan. So that produces in OpenTelemetry compatible format, and then you can just feed it directly into Honeycomb. So that's one agent that you can use. The other thing I wanted to show you was over here. You can see the Kubernetes metrics generated by the Honeycomb Kubernetes agent. So you can see here, for instance, that I'm keeping track of how many workers of each instance class we have. Although we actually ran into a fun one this morning.
Probably can do a pod name starts with Beagle on that one, but yeah.
Yeah, well, first I want to look at the
yeah.
distribution of instances by availability zone. And you can see that for some reason, we were able to scale up much higher in US East 1A than in every other AZ. And that had some weird imbalance effects this morning. So yeah, things that you can discover using, let's see, hopefully this will pull up the correct link. So here's the Honeycomb Kubernetes agent. You can just go and download it from our releases, and there's a Helm chart to just install it. And that's how you get nice little graphs like this, showing info about your nodes. You can also pull the Kubernetes logs using what do we use to pull Kubernetes logs, Fred?
I don't recall. It might be the same thing. It just goes to a different data set. I don't fully recall. I've set it up again recently, but yeah. I don't
basically
recall
you
what
can
handles that
get
one.
data like, oh, that's fun. Yeah, basically you can get your standard out logs dumped into Honeycomb if you really want to. We do not recommend doing this. Let me be clear. We do not recommend dumping raw unstructured logs because it can lead to weird stuff like this. But it's available if you need it. But kind of the primary source of instrumentation is sending open telemetry from your applications and then supplementing with the Honeycomb Kubernetes agent to get the Kubernetes metrics, and then using Kspan from Weaveworks as well.
Yeah, the Kubernetes logs come from the Kubernetes agent as well. You can specify a data set specifically for the logs, and this is what we're using in the Kubernetes agent.
Great, and we dropped a couple of links into chat. So I want to recap. When it comes to this particular chapter of the book, right? There were 4 adjacent practices that we highlighted, which is basically looking at different ways, as we saw in this session, that observability data can affect other practices that are common, when you're managing cloud native infrastructure, right? So everything from incident analysis and everything that Fred outlined in terms of social troubleshooting and ad hoc investigation, rather than relying on the senior most engineer that set up dashboards that then has to kind of read the tea leaves to tell the team what's happening, right? Ways that debugging is democratized. So one, right? Progressive release patterns, right? And using your observability data to inform releases, right? And in tandem with SLOs, right? Looking at how your site is performing, what customer experience is like, and rolling things back or stopping them if your deployments are having unintended consequences.
Yeah, if I had to put a TLDR on my job, is try to find all the feedback loops and make them as short as possible, and just repeat that all the time for decision making. So having all the data is always good for that, and the timelier it is, the better decision making we have.
For sure. We also talked about chaos engineering, right? And ways to look at what's actually happening in your systems, when you run experiments to figure out how things are going to break. And then we sort of talked a little bit about feature flagging. And the one thing that I want to point out about feature flags, right, is that going back a couple of sessions when we talked about having a very atomic unit of measurement, the structured event, right? And why aggregate measures like metrics sort of fall short is, aggregate measures like that tend to look at component by component performance of your system, right? But when, any request can have any different permutation of features enabled, right? That were flagged on or off for a particular user, right? You can't just look at aggregate collective performance, right? You have to look at for an individual request, right? What was the execution path based on which flags were enabled or not? What actually happened, right?
And you shouldn't have to guess which feature flag is involved, right? Like something like Honeycomb's bubble up can highlight the relevant field, namely the feature flag, if it's one feature flag that is coming up that works for everything. right? So, and that can even work, right? Like, yes, it's true, right? Like sometimes the temporal causation is enough of I flipped the feature flag and then things went south. But a lot of the time issues are latent, right? Like we might flip a feature flag, in the case of a thing that happened, this morning, right, where I was showing how the availability zone scale up in US East 1A was significantly higher than on previous days. That latently caused everywhere that we had set the feature flag to have hosts talk to their local worker and their local availability zone, that overloaded the workers in US East 1A. Because everything was reading from them, right? Like that feature flag was set months ago, right? So being able to identify that is really, really key, even if there's not a temporal causation, right? Being able to have those relevant attributes of feature flags be surfaced to you.
And the sort of high-level things that follows is that if nothing correlates to anything, then that's usually a signal that, oh, it's happening outside of what we have observability for right now, and that's a sort of a cue to shift to a different gear and look in other places where we don't have the data at hand. So, it presents on its own as a signal that's super interesting and useful.
Yeah, and what I would say is that when it comes to that complexity that platform developers, right, and platform operators and maintainers now have to deal with, right, what we're looking at is different ways to take granular observability data to understand much more of what is happening inside of all of that complexity. So, sorry, Liz, I think I cut you off.
I was going to say we have time for maybe one or two more questions. So if you have any questions, I think scrolling back, there was a question about kind of what the definition is of inherent complexity. Fred, do you want to take that one? Kind of
yeah.
Why is it that we can't eliminate all complexity from our systems whatsoever?
There's like two levels of complexity, right? One of them is the programmer's definition of it, of essential and accidental complexity. The accidental complexity is usually the technical debt that you have in things that are the result of decisions that were made and how to structure the system. And that's accidental. And the essential complexity is the thing that you can't remove. There's the system view of complexity, where the complexity would be the amount of interactions that can happen when there is an event and there is a need to handle that event or whatever it is that happens. That requires an ability to adapt, to understand, to model, and to have that, and that's some amount of complexity. And sometimes you can't eliminate all the complexity from your system, right? If you need to scale up and you need to go into multiple availability zones and have redundancy, that's going to be, it's not necessarily essential complexity. You want more instances to have redundancy, but to get that redundancy, you need to handle all sorts of events that you didn't have to handle before. And you must program a system that is going to be more complex than what it was extremely simple at a low scale, just to be able to cope with the events and the things that rise up. And some of that complexity gets pushed on users, some is on operators, but there is a need to handle the things that happen, and that's your essential complexity. Unless you can make sure that some things never happen, you're going to have to prepare for them.
And your system never needs to scale. Your system has 0 users, right? Like, right? Like everything is complexity because it's kind of the minimum standard needed to build a system that meets the user requirements.
Right. And all the parts that interact are the same. So even if you do your best to make a lot of small systems that never need scaling up, then you have a need to integrate all of them in ways that they can fail differently. And there's this complexity moves around the system depending on the structure it has. New things can happen and need handling, and you'll never get rid of all of it. There's no way to get a simple system that does everything, because the real world is complex and the programs are a representation of things happening in the real world.
All right, well, I do not see any other questions that have come in. So with that, I wanted to thank George and Fred for joining me for today's presentation. And remember that a link to watch this webinar on demand will be in your inbox soon. So feel free to...
Liz, sorry to interrupt you. I want to plug one last thing. Folks, anybody that's here, if you are in the Seattle area, I posted a link in the chat. This Thursday, we are doing a live book signing. We're giving away copies of the book. If you are in the area and you can attend, check out the link, and we'd love to see you.
Yeah, and go check out that link if you want it. So we've got some great events, both online, the ones on the slides, as well as the link that George has dropped into the chat. And you can find previous webinars and other helpful content at honeycomb.io in our resource library. Thank you for joining us, everyone, and have a happy week.